Hello guys, today we are going to discuss a superposition theorem, and we are going to apply a superposition theorem and find I3 current across a resistance R3. So let's start here in this case. So for superposition theorem, if we got two voltage sources, so first we need to assume the effect of one voltage sources, and we will short circuit the remaining voltage sources. For example, here in this case we have two voltage sources E1 and E2. First of all, we need to remove the effect of E2 potential, and we will consider a E1 potential. So let's start to solve the circuit, and our circuit will look like this. So our circuit is actually look like this. First we need to find the total resistance. Here the total resistance R1 is actually in a series with the R2 parallel to R3. So if we are going to find the total resistance, R1 in this case is 24, and if we are going to apply total resistance formula for parallel, so here 12 plus 4 ohm resistance and 12 cross 4. Now so 12 cross 4, and this is actually 16. So the total resistance here in this case is 24, which is equal to 27. So we found that the total resistance here in this case is 27 ohm. Now the total current here in this case is actually equal to, so we consider the effect of 24 volt resistance divided by 27, which is actually equal to 2 ampere current. So we found the total current I is equal to 2 ampere. Now so let's find the resistance across the current across R3 resistance. So for this we are going to apply a current divider rule. We are applying a current divider rule. So total current is 2 ampere, and R2 resistance is actually 12 ohm, R1 plus R2, so which is actually equal to 36. Now so here I3 is equal to 2 divided by 3, which is equal to 1.5 ampere. Now we found that I3 dash, we put dash because we are dealing with the potential 24 volt, so which is 1.5 ampere. Now if we remove the impact of E1 potential and consider E2 potential. So our circuit will look like this. Now if we remove the effect of E1 potential, so our circuit is actually look like this. Now now if we look into the circuit, R1 and R2 are parallel and a series with so for example, if we are going to find our total resistance, so R3 plus R1 parallel to R2. Now if we put the value, R3 is 4, R1 plus R2 36, R1 cross R2. Now so which is equal to 12 ohm. So we found total resistance, which is 12 ohm. Now for this we put 2 dash and for this we put a single dash. Now actually R3 is in series with these two branches, so the total current flowing across R3 is same with these two branches. So if we are going to find the total current, which is equal to 48 divided by 12, which is 4 ampere, and which is equal to the current across a resistance with the effect of E2 potential. So E3 is actually equal to 4 ampere. Now we found that E3 double dash is equal to 4 ampere. Now if we look into the whole circuit, these two currents are actually opposite with each other. For example, I3 current is opposite with I3 current with the effect of E2 potential. So the total current here in this case is I3, which is I3 double dash minus I3 single, which means that with the effect of E1 and with the effect of E2, which is actually equal to 4 minus 1.5 ampere. So the total current here in this case across R3, the total current here in this case across R3 is actually equal to 2.5 ampere. So we applied a superposition current and find the current across R3. We have many methods to find the current across I3, but here in this case we actually discussed a superposition theorem. So thank you for watching. It's the end of the lecture.